So welcome to chapter 3, where we're going to be talking about polynomials. Polynomials are a collection of terms like we're seeing on the screen here. We were working with polynomials last chapter, just very specifically quadratic polynomials and functions. So in this unit where we're saying, it's all polynomials, we're going to be looking at higher degree. So in this case, that biggest. On the next two examples, we're going to look at the exponents are going to be 4 and 6 for each one, respectively. A lot of the things that we did last chapter, we're going to take them and expand on them moving forward. So there will be some new concepts and ideas in this chapter, but it will be really expanded on from stuff that we did last chapter. So this is kind of a natural progression. Now we're going to kind of apply things that we learned with quadratic functions and do it with bigger functions. And when I say bigger, it could be more terms, could be higher degree, whatever. In this lesson, we're going to be looking at classifying polynomials in 3 different ways. So as you can see in the question, leading coefficient, we'll talk about that in a second. The degree can be the highest degree that you see out of all the terms, and then the number of terms. Standard form is what you're going to want to get the polynomial in to start. So let's look at that on the right first. Standard form of a polynomial shows any like terms combined. So if in this example we had 2 linear terms, you would add them together. They wouldn't count as 2 separate terms, right? And then you place them in order of degree, descending. So the biggest one first, the next biggest one second, and then the smallest one third in this case. So 2x cubed minus 4x plus 9 would be the standard form of what we started with there. The leading coefficient is the coefficient of the term that has the highest degree. It's called leading because when it's in standard form, it will come first. So in this case, the leading coefficient is 2. The degree of the polynomial is, in this case, based off of that first term. So the degree of this polynomial is 3. And that's also known as a cubic polynomial. As we talked about last chapter, when the biggest degree is 2, it's a quadratic, as you learned back in Algebra 1, when the biggest exponent is 1, or just a regular variable. It's a linear function. Again, 3 is cubic, 4 is quartic, 5 is quintic, and then beyond that, I don't even know off the top of my head, and it's also not necessary. You just need to say it's degree 3, 4, 5, 6, whatever. And then the terms of a polynomial, in this case, there's 1, 2, 3 separate terms. Terms are separated by plus and minus. And again, like we said earlier, you're not going to count like 2 linear terms are not going to count as 2 separate terms. Standard form, they'd be combined. Anyway, so since there's 3 terms, this is a trinomial. If there were 2 terms, it'd be a binomial. If there was 1 term, it'd be a monomial. They're all polynomials, right? These are just special names for certain polynomials. Anything that's more than 3, so 4, 5, 6, whatever, you would just say it's a polynomial with 4 terms. There's no other name for it than that. Looking at these 2 examples, I'm going to pause it, and you can get it in standard form, identify the leading coefficient, identify the degree, and identify the number of terms. All right, so pause it now, try that, and then we'll compare answers. So in the first one, when it's in descending order, you have negative 3x to the fourth minus 5x cubed plus 2x plus 6. Notice that the subtraction follows the term. So since it was minus 3x to the fourth in the original, that negative followed it. The leading coefficient is that negative 3. The degree is 4 based on the biggest exponent being 4, and there are 4 terms. For the second one, it's 2x to the 6th plus x to the 5th minus 3x to the 4th plus 4x cubed minus 8x. The leading coefficient is 2. The degree of the entire polynomial is 6 because of the 6 being the biggest one there, and then there are 5 terms. All right, let's take a look at the next example.